to look now at factoring completely and identifying the zeros of a quadratic equation that's written in standard form. Again, standard form of a quadratic equation is always written as y is equal to ax squared plus bx plus c. So in order to factor this, what we need to recognize is that the bx value right here, this b value, is what we're looking to add to, and the c value at the back end is what we're looking to multiply to. So this is where we set up what we call our AC chart. Okay, so they have to multiply to the C value, and they have to add to the B value. So what I'm going to do is I'm going to try and figure out which terms actually meet this requirement. So I'm going to plop in what they need to multiply to. So here I know that I need two numbers that are going to multiply to negative 27, and at the same time they have to add to negative 6. So I'm just going to go through and try and identify all of the multiples of negative 27. So I know, 1 times 27. Well, one of them has to multiply. I could go 2. Well, 2 doesn't work, okay, because there's nothing that multiplies by 2. 3 times 9 will give me 27. Okay, and if I keep going, it'll give me some other factors here. But because I've got a negative 27 at the back end, that means that one of these numbers has to be positive and one of these numbers has to be negative. So if I do positive 1 and let's say call this negative 27, that's going to result in, they're going to add together to negative 26. If I switch those around and I made the 1 the negative, then I'd end up with positive 26. If I have negative 3 times positive 9, that's going to equal negative 27, and when I add them together, that's going to equal positive 6. But if I take positive 3 multiplied by negative 9, that's going to equal negative 6. So my two numbers are going to be right here, 3 and negative 9. So I'm going to write in x plus 3, x minus 9. Okay, so those are going to actually form my my factored form. If I want to be able to identify the zeros of this form, I need to figure out, well, what value of x, or what values of x rather, do I need to put in here in order to make this equation equal to 0? So right now we have two terms that are multiplied together. Some number, x plus 3, times some other number, which is x minus 9, has to equal 0. And for that to be true, one of those two terms has to equal 0. So if I substitute in negative 3 plus 3 equals 0. So 0 times whatever number on the other side is going to equal 0. And if I have an x minus 9, well, the opposite of that is positive 9. Okay, so my zeros equal negative 3 and positive 9. Every single thing that we're factoring is set up like an ax squared plus bx plus c equation, even when there's something that's missing. So for example, in the second example here on the right, I've got an x squared plus 36x, but it looks like there's no c value. Well, if it looks like there's no c value, there is a c value. It just happens to be 0. Okay, so this is now a trinomial. So we always want to make these things trinomials. So again, I need to set up my MA chart. So I know that the two numbers have to multiply to 0, and they have to add to positive 36. So I know that they are going to multiply to 0, and they're going to add to positive 36. So I know right off the bat that any number, any two numbers, if one of them is multiplied by 0, it's going to equal 0. And I need something that will add to 0 that equals 36. positive 36. So in this case, positive 36 is what it is. Okay, so 0 plus 36 equals 36. So obviously 0 and 36 are going to end up being my two factors. So I've got x plus 0 times x plus 36. Okay, if I want to figure out what my zeros are for this equation, I need to figure out, well, x plus 0 is something has to equal 0. So 0 plus what equals 0? Well, 0 plus 0 equals 0. And some number plus 36 has to equal 0. So what number plus 36 equals 0? Well, it's actually negative 36. And again, it's the same number, just the opposite sign. So here, my zeros are equal to 0 and negative 36. If I continue down, two more examples. Here, this is also on the left-hand side. I've got x squared minus 16. So this doesn't look like a trinomial right off the bat. So I need to change it so that it is a trinomial. Well, I've got ax squared. I've got an x squared term plus bx plus c. Well, my c term is negative 16. My a term is 1. Okay, and that's being multiplied by x squared. So this is actually x squared. I don't have a bx. That means it's actually 0x, okay, because 0 times x equals 0, minus 16. Okay, so again, I got to make up my MA chart. So I need two numbers that are going to multiply. I'll change that color actually. So I need two numbers that are going to multiply to negative 16, and they have to add to 0. Okay? So in this case, I need two numbers that are going to multiply to negative 16, and at the same time, they have to add to 0. So what numbers multiply to negative 16? Well, one of them has to be a positive number, and one of them has to be a negative number. So if I do positive 1 and negative 16, that's going to add together to be negative 15, so that doesn't work. If I do negative 1 and positive 16, those are going to add together to give me positive 15. If I go 2 and negative 8, that gives me negative, they multiply to negative 16, but it's not going to add to negative 16. If I add those things together, it gives me negative 6. If I do the opposite, that actually multiplies to positive 6. Negative 16 is not divisible by 3, so I'm not even going to worry about it. If I do positive 4 times negative 4, that will multiply to negative 16. And if I take 4 plus negative 4, that equals 0. So because 4 plus negative 4 equals 0, that means that this has to be my connection. Okay? And so as a result, I know that my factors here are actually x plus 4 and x minus 4. Okay, so now if I want to know what my zeros are, I know that my zeros has to be the opposite number as what's in here. So here I've got a plus 4 on the one end, so here x has to equal negative 4, and I've got a negative 4, so here x has to equal positive 4. Okay, so my zeros are negative 4 and positive 4. Finally, if we come over here on the right-hand side, the last one, now this one's a little different because in this instance, we actually have a trinomial, but our a value is not positive 1. Every other time we've done this, we've had an a value of positive 1. So the first thing we actually need to do is make the a value positive 1. Here, our a value is equal to 2. And so what we need to do is actually divide out every single term, these three terms, out by the a value. So we're going to actually divide all three of these numbers by positive 2. Okay. Now we're not going to lose this 2. Okay. This 2 is not going to just disappear. So what we're going to do is we're going to carry it through. Okay. And so as we're carrying it through, we have to recognize that there's now a 2 out front, and then 2x squared divided by 2 just leaves us with x squared. Negative 4x divided by 2 leaves us with negative 2x. And negative 6 divided by 2 leaves us with negative 3. Okay. If we go through and we make our MA chart, we know that the two numbers that multiply together, they have to add to negative 2, and they must multiply to negative 3. And so if we make our MA chart, okay, they're going to multiply to negative 3, they're going to add to negative 2. So what numbers will multiply to negative 3? Well, 1 and negative 3, when you multiply those two numbers together, you get negative 3. And when you take positive 1 plus negative 3, you end up with negative 2. So our factors here must therefore be positive 1 and negative 3. And so our zeros, therefore, must also be the opposite of what's the opposite of the number that's in there. So x is going to become negative 1. This x is a positive 3. So positive 3 minus 3 is 0. Negative 1 plus 3 is 0. So our zeros are negative 1 and positive 3.